Hey 11s, welcome back to school. This is exercise 10A on addition and multiplication principles on page 368 of your textbook. Now, you're wondering why we're skipping from probability jumping into counting methods. Well, in the interest of time, I really feel like counting methods is a new concept that we don't cover in previous years, and some of probability might be stuff that you guys already know, so we're going to jump into counting methods. Now, counting methods is a little bit different from probability in the sense that with probability, we're looking at, okay, well, if I have to randomly choose one, what would the chances of me getting a certain scenario be? Whereas counting methods is more like, if I've got all these different options, what is the total number of options that are available? For example, if we're picking a very, very simple example, if I've got different colored marbles in a bag, well, if I was to pick three, let's say, if I was to pick three different marbles, what would be the different possibilities for those? And if I can calculate that, well, how many possibilities are there? So if I'm going to read off the screen, we can say that when determining the probability of an event, we often need to know the number of outcomes contained in the event and in the sample space. When dealing with more complicated probability problems, listing the sample space in the event becomes too difficult, as there may be hundreds of outcomes for one experiment. So if I go back to the probability example of picking marbles out of the bag, what happens if I'm saying, well, how many possible ways are there for me to pick 100 different marbles? 1,000, right? At that stage, it gets way too ridiculous to try and do it by hand. So we try and apply some addition and multiplication principles, or the and/or principles, as I like to call it. So I'm actually going to jump to and from. This exercise doesn't have too many concepts to focus on besides these two, so I'm going to focus on the example one. Now, example one says, Sandy cannot decide whether to wear a wind cheater or a jacket. She has 4 wind cheaters and 2 jackets. How many choices does she have? In this example, we're referring to the addition rule. And the reason we're referring to the addition rule is because, well, the addition rule is often indicated by the word or. Okay, so in this situation or this scenario, we can see that she's saying either a wind cheater or a jacket, right? And in the or situation, well, you're just going to go ahead and add them. She has 4 wind cheaters, so obviously the situation is 4 wind cheaters plus 2 jackets, which very simply gets us 6 options. Now, you didn't need a formula to tell you that. You know that there's 4 wind cheaters, 2 jackets, a total of 6 options. Pretty straightforward. But it's where we have a combination of different possibilities that gets a bit odd. So in the second question, it says, consider Sandy's situation again. She has 6 choices for wind cheaters or jackets and 7 choices of jeans or skirts. So how many choices does she have for a complete outfit? Now, in this situation, we're saying wind cheaters or jackets is one side, one option, and then the second option is jeans or skirts. Okay. Now, you can see here it says and. Okay. Now, typically in probability or counter methods, we say, well, what's the probability of getting, and I'm going to pick a very cliche example, what's the probability of getting a heads and then a tails? Or what's the probability of getting a green marble and a red marble? So and scenario presents us with something where we use the multiplication rule. When sequential choices are involved, the total number of possibilities is found by multiplying the number of options at each successive stage. And that's very similar to stuff we've already done in probability in previous years. And we can see, okay, we've got 6 choices for wind cheaters or jackets. I'm going to go ahead and try my best to draw a shirt just to show it's the top of the clothing. And then jeans. Let's just draw jeans. There we go. So I have 6 on top and 7 options on the bottom. So what I can say is I can multiply them. I can go 6 times by 7, which gives me 42. Gives me 42 options for these different things. So if I was to pick a certain wind cheater and a certain jean and then go ahead and change up the order, etc., you can have 42 different possibilities. Okay, now this is probably reminiscent of the tree diagram we've used in the past. If I'm focusing on, for example, let's say I've got I've got a coin flip, coin 1, and then I've got coin 2 over here. This should be relatively familiar to you. There we go. And you can see here I've got heads, tails. You know what, I'll do that in different colors so we can see. Heads, tails, heads, tails, heads, and tails. Now each one of these is a half possibility. But let's say, just for argument's sake, that we have a rigged coin. That it takes 1/4 or 25% chance for it to be heads, or 3/4 for it to be tails. So I'm going to go ahead and just label these over here so that you can see. But this is not really for calculation's sake, this is just to show you the principle. As you can see, if I was trying to say what is the probability of finding a heads and a tails, actually let's pick an easier option. Let's say heads and a heads. To find that, well, I wouldn't just add them together, because I'm saying, well, after the first flip, it's a 1/4 chance of getting a heads, isn't it? And then the second flip, to get a heads again, we multiply by 1/4 to give us 1 out of 16. So remember, if we're working with and, so what's the probability of getting this and that? Then we use the multiplication rule, just like we do in probability. Whereas if this question typically says, what's the probability of getting this or that? Then we would use the addition rule and we just add up the options there. Very brief video. Hopefully it makes sense. Best of luck and ask me if you have any questions.